Geothermal power plants. Geothermal power plants draw from underground resources of steam. The steam is piped directly from underground wells to the power plant. Where it is directed into a turbine and generator unit, and the heat energy is converted into electricity.
Steam power plant.
Steam power plants are widely utilized throughout the world for electricity generation, and coal is often used to fuel these plants. Although the world's existing coal reserves are sufficient for about 2 centuries, the technology largely used today to produce electricity from coal causes significant negative environmental impacts. According to Rankine, in general, a steam turbine is a rotary heat engine that converts thermal energy contained in the steam to mechanical energy or to electrical energy. From thermodynamics point of view, the performance of steam turbines can be derived from theory of Rankine cycle, which is an idealized thermodynamic cycle of a constant pressure heat engine that converts part of heat into mechanical work. The Rankine cycle is an idealized thermodynamic cycle of a constant pressure heat engine that converts part of heat into mechanical work. In this cycle, the heat is supplied externally to a closed loop, which usually uses water in a liquid and vapor phase as the working fluid. In contrast to the Brayton cycle, the working fluid in the Rankine cycle undergo the phase change from a liquid to vapor phase and vice versa.
The goal of our group on the first day was to make a 3D diagram on a mini geothermal power plant that shows how it works. Last year, we were able to show that it needs more fire or temperature to make a higher amount of steam and pressure to produce much electricity needed for the 12V LED lights to turn on. Basing on the website, Geothermal explained, geothermal power plant use hydrothermal resources which have both water, which means hydro, and heat, which means thermal. Geothermal power plant requires high temperature and hydrothermal resources that came from hot steam wheels and hot water wheels. Using the following materials, we were able to make 3D diagram.
We have aluminum wire, flat screw, stainless steel pipe, empty cans, elbow 15 pipe, also 1/4 PVC pipe, soldering lead, 3 LED lights, 3 switch 200V, positive and negative wire, direct current motor 12V, plywood, heat shrink tube electrical insulator, epoxy, adhesive glue, glue stick, bottle caps, G-bolt with nut and washer, and then water.
So good morning everyone. On trial 1, we tried using only one candle to produce steam. When we contact the fire on the can with the water inside, it produces steam but not enough for the propeller to generate electricity to light the LED bulb. On trial 2, we used 2 candles at the same time. We observed that there is improvement compared to the first trial, and it can now generate electricity and can lights on the LED, but the problem is there is this tendency of blinking, or in Bisaya term palong-palong bitaw, right? And then it happened that the steam produced is not enough to have a stable electric supply. And then on trial 3, excuse me, we used the butane torch, and then the heated water produced much steam, which will make enough electricity to light on the LED lights for a specific period of time. By that time, we're able to show that it works on the series circuit. Now we were challenged to try it with a parallel circuit, so we change our objectives and do some revisions on the materials in a series circuit. So there is only one path for current to flow. Now the challenge is it is different for the parallel circuit. The basic idea of a parallel connection, on the other hand, is that all components are connected across each other's leads. In a purely parallel circuit, there are never more than the two sets of electrically common points, no matter how many components are connected. So there are many paths for current flow, but only one voltage across all components.
We observe 3 trials in testing if it works on the parallel circuit connections. On trial number 1, we encountered a problem because the propeller was not spinning, so it cannot generate electricity to light the LED bulb. On trial number 2, we observed that there is improvement compared to trial number 1. It can now generate electricity and can light on the LED bulb, but we were not contented on the result. We want it more to be sufficient to supply the flow of the electric current. On trial number 3, the heated water produced much steam, which will make enough electricity to light on the LED lights for a specific period of time. In general, the generation of the electricity will much be affected on how the propeller spins, as well as the steam produced during the heating.
For the future researcher, we recommend that they should construct a steam engine. But if they want to proceed with steam turbines, we suggest putting a casing in the turbines so that the steam flow can be guided directly to the blades.